Okay, we're going to look at geometry proofs where they ask you to prove things, and we use all our reasons to manage that. Let's look at the first example I put in the notes. I'm just going to explain it so it makes it a little bit easier for you to follow. It says here that CD is a tangent at C. So this line here is a tangent right at that point C to the circle through A, B, C, and E, this whole quadrilateral here. BC equals CE, so those chords are the same length. And AC and BE intersect at F. Okay, those lines cross right there at F. They ask you to prove that C1 is equal to A2. Well, we start with C1. We're trying to get it to A2, but this is a triangle here. Here's the tangent. C1 is an angle between the tangent and this chord BC. And A1 is the angle up in the top that subtends that chord. So it's equal. C1 is equal to A1, and we got a name for that. It's called the Ten Chord Theorem. So that's our first step. Well, A1 and A2 both open up. They both subtend the segment of the circle EC here and BC here. They both subtend these chords that are of equal length, so they must be equal. So A1 equals A2, equal chords, equal angles. So those angles must be equal. Now, if C1 equals A1 and A1 equals A2, it makes sense. And the way everybody over here just writes, they go, therefore, C1 equals A2. Well, there's a special name for that. You don't have to put it in, but I like it, and I think about it. It's a rule of logic. And this is all about logic, so I would put transitive property there, but maybe I'd get it wrong. So a transitive property is what's going on. That's the reason you can say C1 is equal to A2. But you don't have to write it. And maybe you shouldn't write it, but that's the rule of logic that's going on. Okay, so let's look at the next question. They want you to prove that C4 is equal to E2, that this C4 is equal to E2. Well, we can start off by saying C4, the angle between the tangent and the chord, equals the angle at the top of this triangle, AEC. So C4 equals A2, Ten Chord Theorem. A2 equals A1, same thing, equal chords, equal lengths. But and because C4 is equal to A2 and A2 is equal to A1, then C4 must equal A1. That same transitive property that we don't write in there. Now we can say that A1 equals E2. But why is that? Because they open up to the same chord, angles in the same segment. Well, if C4 equals A1 and A1 equals E2, then C4 must equal E2. Okay, so forget that transitive property. Okay, the next example. It says that O is the center of a circle, SAT, inscribed in triangle PQR. So there's a big triangle PQR. PQ, QR, and RP here are tangents. They fit right going through the points A, T, and S. They are tangents for the circle. And we're supposed to prove that PSOT, this quadrilateral here, is a cyclic. That is, that we could put a circle around it. We could put a circle around it. Well, the first thing we know is that T1 and T2 together, that's a tangent. It's perpendicular to the radius, so that's 90 degrees. And S1 and S2 are equal to 90 degrees too, because this tangent is perpendicular to the radius. But hey, those two opposite angles inside this quadrilateral add to 180 degrees. Then you can say PSOT is a cyclic quadrilateral. Why? Because the opposite angles are supplementary. And that's it. That's it. The opposite angles of a quad are supplementary. Okay. Let's look at this next question. It says, prove that OS is tangent. This line right here is tangent to a circle SPE. What does that mean? You're supposed to prove that you could fit a circle so that it would touch S, E, and P. So there is you want to have it so that you could put a circle right like that, right, that would pass through S, P, and E. We want to prove that that's true. Okay, well, let's try this. Let's see what's going on. First one, S1 equals T1. Well, S1 and T1, those are radii. So that's a triangle, equal angles, angles opposite equal radii. So that's the reason there. Now P2 equals T1. Well, P2 opens up and T1 both open up to OS, and we just proved that's a cyclic quadrilateral, so those two angles must be equal, angles in the same segment. And we know that if S1 is equal to T1 and P2 is equal to T1, then S1 equals P2. That means S1 is equal to P2. Well, that means that OS must be a tangent to a circle that fits right on this triangle SPE. And why is that? It's because the angle between the line and the chord, because the angle between the line and the chord equals the alternate interior angle in the triangle. That's right. It's kind of the converse of the Ten Chord Theorem. And you can write that, converse of the Ten Chord Theorem. Okay, hopefully this helped to explain these kind of questions. They're a little bit trickier, but maybe now you can do them.